For today, we're going to start a new chapter, Chapter 5, Classification of Soil. So first, I want to refer to this course objective list again. In classification, classify soil for engineering purposes is one of our main course objectives. And so far, we have discussed grain size distribution, Atterberg limits, and plasticity. And all are basically getting us ready for this chapter here. So we're going to use what we have learned so far to classify soil for engineering purposes. And first thing I want to discuss is the role of this soil classification system. So why do we need a soil classification system? As I mentioned, so far, chapter 2, 3, and 4, we have discussed particle size distribution, or PSD, Atterberg limits, plasticity, and all these index properties. These are called index properties. And for engineering purposes, like design foundations, dams, highways, airfields, you need to know the engineering properties of soils. That includes permeability, compressibility, strength, shrinkage, swell potential. And there is a missing link between what we have discussed so far and engineering properties. So the soil classification system is actually that linkage here. So it's that link. So given index properties, so all these particle size, Atterberg limits, plasticity, and we fit that into basically soil classification system. And then by classifying soil into different groups, we know the probable engineering behavior of that soil, of that group. So soil classification really is this missing link. So you can think of this as a basic communication language of geotechnical engineers. So if I know the classification of that particular type of soil, I have some idea, some pretty good idea of what are the probable engineering properties of that soil. And again, that properties are what you need for engineering purposes, for design, for construction. So soil classification is really that missing link in that communication language there. And to classify soils, we are going to use particle sizes, distribution, and Atterberg limits. So we're going to use all these index properties to classify soils. And I'm going to go over details of soil classification systems today. And first, there are different types of classification systems. In this class, we're going to focus on this USCS, or Unified Soil Classification System. So that's what we're going to focus on because this is the most widely used in geotechnical engineering, and this is required for this course. But there are other classification systems. And another very commonly used one is this AASHTO system. So this is mainly for state and county highway departments. So they use this system to classify soil for highway systems. And I've listed here, chapter 5.4 of your textbook actually covers details of this AASHTO system. For both this USCS and AASHTO system, they take into account particle sizes and its distribution, and also the Atterberg limits or plasticity of soils. So both systems consider these particle sizes and plasticity of soils. And there are other systems where they only use particle sizes, for instance, for classification. But for these two systems, they consider both particle sizes and plasticity. And I'm going to go over this Unified Soil Classification System, or USCS. And just a little bit background, this USCS system is the original form of this system is proposed by Arthur Casagrande. I briefly actually mentioned his name in the last lecture when we talk about Atterberg limits. And this is for use in construction of airfield during World War II. And later, that original form is modified by Department of Interior and U.S. Army Corps of Engineers. And that modified revised version become an ASTM standard. And that's what we're going to discuss today. So I'm going to go over the details of this system and how to use this to classify soils. And to use this system, we need a few pieces of information. So just a quick review of what we have discussed so far. First, the particle sizes. So this is chapter 2, original soil and particle size. And in chapter 2, we talked about different types of soils, gravels, sands, silts, and clay based on their particle sizes. And for these two systems, the AASHTO system and USCS system, and they use different particle sizes to classify soils into gravel, sands, and fines, or gravel, sands, silts, and clay. So that's particle sizes. And for our course, this USCS system, this is required. So for this one, there are 3 key numbers. One is 76.2, so that's the upper limit of gravel. 4.75, that's the limit between gravel and sands, and then 0.075 between sands and fines. Okay. And the second part is this PSD, particle size distribution curve. So recall this is a curve basically showing you the sizes, the particle sizes and its corresponding percentage. So this is a semi-log plot. And from particle size distribution curve, what we're going to use for a USCS system are these 2 indices, or these 2 coefficients. One is called the uniformity coefficient, CU, and the other one is coefficient of gradation. So specifically given a PSD, we're going to get these 2 coefficients and use them when we are trying to classify soils in the USCS system. Okay. And CU and CC, they're used for determining the gradation of soil. And this is PSD. Just last lecture, we concluded chapter 4. So that's on Atterberg limits and plasticity. From Atterberg limits and plasticity, we're going to use this actually plasticity chart. So something I talked about last lecture. In plasticity chart, remember it's liquid limit versus plastic index chart. And we're going to use this chart to help us determine if the fine contents are silts or clays. In plastic index, just a review, it's difference between liquid limit and plastic limit PL. All right, so that's a very quick review. And then I'm going to introduce this USCS system in details. So in the USCS system, a complete classification has 2 components. So the first one, so I'll start with group symbol actually. The first one is group symbol. And the second part of the USCS system is the group name. And this is a difference between the USCS and AASHTO system. So in the USCS system, the group symbol and group name, they are descriptive. So meaning they communicate specific informations. If you look at the group symbol and group name, you can immediately tell what kind of soil it is. The AASHTO system, on the other hand, uses just letters and the numbers. So the names in AASHTO system, they are not descriptive. So you need to refer to a table to really get the meaning of what A1 is, A2 is, A3 is. Okay. For a US system, so the first thing I want to go over is those symbols in USCS. So the first part of the member of the USCS system is group symbol. And there are a number of symbols in the USCS system. And I classify them into soil symbols, plasticity symbols, and gradation symbols. I'm going to go over all of them. The first one, soil symbols. There are 6 soil symbols. So I'll start with the first one. So the first soil symbol is G, stands for gravel. And second one, S, this stands for sand. And then M stands for silt, and C for clay. Again, as I mentioned, those are descriptive names. You see letter G, you can immediately link that, relate that to gravel. And the other remaining 2 are O for organic silts and clays. And last one is P, small letter T. And this is for peat, muck, and highly organic soil. So that's the first group of symbols, soil symbols. And these are very, very descriptive. So you see the letter, you can immediately link that to a particular soil. And the second group is plasticity symbols. And there are 2 letters for plasticity symbols. First one is L for low plasticity. And the second one is H for high plasticity. That's plasticity symbols. And the third group are gradation symbols. And gradation symbols also there are two. W for well graded and P for poorly graded. So those are all the symbols in the USCS system. And for gradations, remember this is something we cover in chapter 2, and you can use CU and CC to determine if soils are well or poorly graded. For gravels, for instance, CU greater than 4 and CC between 1 and 3 are the conditions for well-graded soil. And for sands, CU greater than 6 and CC between 1 and 3 are conditions for well-graded soil. Okay. So that's symbols in USCS system. And next, in the USCS system, soils are put into two broad categories based on the percentage of fines and coarse-grained soils. So the first category is called coarse-grained soil. And for coarse-grained soils, more than 50% of the particles are retained on or above number 200C. And this simply means more than 50% of the soils are gravels and sands. Okay. So that's the first broad category, coarse-grained soils. Okay. More than 50% are gravels and sands. The second category is the fine-grained soils. For fine-grained soils, this means less than or equal to 50% of the soil they retain. Okay, so let me actually write it this way. So I'm going to modify this size slightly. Okay, so I'm going to write using larger than or equal to. So for fine-grained soils, more than 50% they pass number 200C. And that means more than 50% of the soils are fines, which includes silts and clays. And those are the two broad categories. There's actually another one that's highly organic soils. Highly organic soils are characterized by basically dark in color and organic odor. And for this course, unless it's explicitly given, we're going to assume all the soils are inorganic. And that's where we're going to use particle sizes and Atterberg limits to classify soil. So these are the two broad categories. So then to classify soil using USCS, first you need some information about the soil. So basically those are the index properties. So we need the following information. The first one is from sieve analysis. You need the percentage of different types of soil, percentage of gravel, percent of sand, percent of fines, CU, and CC. So you need some or all of the following information. And for how to obtain how to obtain these different types of soil, the percentage of different soils from a PSD. So this video, this is on our YouTube channel. So this is a PSD curve basic video, and that covers how you obtain this information if you're given a PSD. And then from Atterberg limits, something we discussed last week. You need liquid limit and plastic index, which is defined as LL minus PL. So you need these pieces of information. And then once you have this information, then you need classification tables. For our textbook, table 5.2, figures 5.3 to 5.6 are the classification tables you need to determine group symbol and group name. Okay. And then the next are just some step-by-step instructions. So I'm going to go over these instructions. But before that, let me show you what these tables look like. The first one, this is table 5.2. This is the main table to obtain group symbol. And I'll come back to this in just a little bit, explain all these details, all the details here. So this is table 5.2. Figure 5.3 is that plasticity chart. So that's what you use to determine the fine contents to tell if they are silts or clays. And then 5.4 to 5.6, these three figures are group names. So remember, USCS system consists of group symbol and group name. So 5.4 to 5.6, these figures are used to determine group names. Okay, now to this step-by-step instruction. So I'm going to go over this in detail with you, and we're going to go over at least one example today. For step-by-step instruction, the first step is to determine particle types and their percentage. So basically, these are from sieve analysis. It's like, so there are two scenarios basically. One is you are given a PSD curve, and then you obtain these percentages directly from the PSD curve. So that's one scenario. The other scenario is you are given basically the sieve analysis data directly. So you're given the percentage passing for a specific sieve number. And you can also get these percentages from that table as well. Okay. And we have homework problems or examples for both types. And for percentage of fine, so it's percent smaller than 0.075 millimeter. Okay. So if you're given PSD curve, you can get the percentage finer than 0.075 millimeter from a PSD curve. And if you're given the raw data of sieve analysis, then percentage of fine is basically the percentage passing number 200 sieve. And then percentage of coarse, this is some percentage larger than 0.075. And this is percentage of soil retained on or above number 200 sieve. Then percent of gravel, and that's percentage greater than 4.75 millimeter. And this is basically that number 4 sieve size. So it's a percent retained on number 200 sieve. That's percent of gravel. And then sand, so it's percent between 0.075 and 4.75. So that's a percent of soil in between these two numbers, these two sizes. And it's basically, if you have percent of gravel and percent of coarse calculated, it's the difference between these two. So that's a percent of sand. So that's the first step, basically getting all these percentage of different types of soils. And second, once you have that information, is to determine if soil is fine or coarse grained. So if fine percent greater than 50%, that's a fine grained soil. And if you have more than 50% of the soil being coarse, that's coarse grained soil. And remember, these are the two broad categories in the USCS system, fine grained and coarse grained soils. And this will determine which portion of that table 5.2 you need to use to get the group symbol. Again, I'm going to go over details on that table. This is step 2. And then step 3, using that table 5.2 and also along with that plasticity chart. So you're going to find out the group symbol. So determine the group symbol first. And to do that, so you're going to enter from the left side of table 5.2 and then use the information you calculated from 1 to 2 to determine to move to the right, basically, to find the group symbol. Okay, so let me show you what this table looks like. So this is that table 5.2. And in this table, as I mentioned, you enter from the left. And if you enter from the left, you will see there are two broad categories, that coarse grained soil and that fine grained soils. And then you move basically to the right-hand side using the information you calculated from step 1 and 2. Eventually, you're going to exit on the right-hand side and find the group symbol. So that's what you get from table 5.2 group symbol. And so I put a note here. As you move along the table, you need to pay special attention to the dual symbol cases. So these footnotes, basically. So if you look at these footnotes, so these footnotes are for dual symbol cases, and that's particularly challenging for this classification system, these dual symbol cases. And that's where I find many students struggle with this USCS system, is dealing with these dual symbol cases. So I created additional instructions. Okay. So dual symbol cases. So this is a little bit tricky. I'm going to go over dual symbol cases for coarse-grained and fine-grained soils. So they are slightly different. For coarse-grained soils, the dual symbol cases are, let's say, for the first part of the dual symbol relates to the gradation of soil. So let me show you one example. So look at this first footnote A here. Okay. Footnote A, you see all these are dual symbol cases. And you'll notice that the first part of the dual symbol is either GW or GP. So that means it's either well-graded gravel or poorly graded gravel. So the first part of the dual symbol relates to the gradation. And to determine that, you need CU and CC. So that's what's shown here. So use CU and CC to tell you if the gravel or the sand are well or poorly graded. So that gives you the first part of the dual symbol. And the second part of the dual symbol for coarse-grained soil relates to the plasticity or the fine contents. As shown here, if fine contents are silt, it will be M. And if fine contents are clay, it will be C. So again, let's look at that table. Again, we're going to use this footnote A here. So footnote A, as I mentioned, first part relates to gradation. It's either GW or GP. And then the second part relates to fine contents. It's going to be either GM or GC, depending on the fine contents. So and to decide which fine contents are in the soil, you need plasticity chart. So this is something we covered in the last lecture. If the soil plots above a line, the fine contents are clays. If the soil is plotted below, the fine contents are silts. So that's the plasticity chart. And one additional note I added here, if you know the fine contents are non-plastic, if it's not plastic, then they are going to be silts. So silts are fine particles without any plasticity. Okay. So if you know it's non-plastic, you know the fine contents are silts. Also, there's one exception. So this is footnote D here. That's why I said dual symbol cases are tricky. So footnote D here, table 5.2. So this one here. Okay. So for footnote D, if PI, plastic index, is between 4 and 7, and plots in the hatched area in the plasticity chart, then the dual symbol case would be GCGM or SCSM. Okay. So if you look at plasticity chart, so this is the hatched area. So if your PI is between 4 and 7 and it plots in this hatched area, it's going to be either GM, GC. So that's if your coarse-grained soil, coarse components are gravels, or SC, SM if your coarse-grained components are sands. Okay. So that's a special case. And then for fine-grained soil, this is simpler than the coarse-grained case. Dual symbol cases for fine-grained soil is actually pretty straightforward, just using the plasticity chart. So use plasticity chart if PI between 4 and 7 and plots in a hatched area in the plasticity chart, then the dual symbol case is CL and ML. Okay. So that's a dual symbol case for fine-grained soil. All right, so once you have that, then the final step, step 4 of USCS system is to find group name. So once you get that group symbol, and then the final step is to find the corresponding group name. And to do that, as I mentioned, you use figures 5.4 through 5.6. Okay. So that's that group name figures. So one thing, that group name figure is relatively easy, very straightforward to use. But one thing I want to point out on that group's name figure. Okay. So this is where I get most questions on group names, is that what does that X% plus mean? One example is this CL here. So I highlight here. So for instance, smaller than 30% plus number 200. So that plus simply means it's larger than, or it's retained on number 200. Okay. So let's say 30%, smaller than 30% plus number 200. So this first case, it simply means smaller than 30% of the soil is retained on number 200 sieve.